Okay, so finally, we have the limits involving exponential function, logarithmic, inverse functions, um, hyperbolic, inverse hyperbolic functions, and the other trigonometric functions. Now, um, actually, I don't have any tips for this one, rather than other than to memorize the graphs of your functions, so that you will not um you don't need to remember the limits but rather the graph, and then from the graph determine the behavior of your function so you can get the limit of your function. So I'll give you an example. So for example, exponential function, we have two graphs that you need to remember. So for the exponential function, the case when a is greater than 1, we have the following graph. And as you can see, as x goes to negative infinity here, the graph goes to 0, and therefore we can remember that the limit of of our function f as x goes to negative infinity goes to 0. Similarly, as x goes to infinity, our graph increases and goes to positive infinity, and therefore the limit of f as x goes to positive infinity is equal to infinity. We can also remember some important points here in the exponential functions. So one point would be e raised to 0 is always equal to 1. So from this one graph, you can determine two limits and points. And so this is why I am recommending to remember memorize the graphs of the function. And now, if you're solving the limits of functions involving this function, exponential functions, then we can just use the graph to determine the limit. Another graph of the exponential function is when a is between 0 and 1. So this will be the mirror image of our graph. Now, as x goes to negative infinity, it goes to positive infinity, and then as x goes to positive infinity, it goes to 0. Same point here that e raised to 0 equals 1. Another case that I can show you is when we have a logarithmic function. So a logarithmic function of x to the base a, when a is greater than 1, this is the graph. So it's increasing, and therefore as x goes to positive infinity, this is positive infinity. And then the limit of f as x goes to as x goes to 0, as you can see here, since we don't have any negative number and the graph only almost touches the y-axis, that is when x goes to 0 from the right, and the limit of that one would be negative infinity. The other case, when a is between 0 and 1, we have the other graph. So as x goes to 0 from the right, the limit now is positive infinity, and as x goes to positive infinity, the limit is negative infinity. I will not be showing you some examples. It's up to you to solve it, and we already have so, so many exercises in the Unit 1 handouts, notes, so you can do it on your own. I also want you to remember the graphs of the other functions, specifically the inverse functions. Most probably if they maybe the graphs of the inverse hyperbolic functions will not be given. The same thing that we did for the Unit 1 long exam, wherein some graphs are given. So that can be a possibility. But as much as possible, remember the graphs of the other functions. Okay. Next, we have the inverse functions. So when evaluating the limits, I want you to remember the range of the values of your inverse functions, specifically for sine and tangent inverse. The range or the values that it can only take is from negative pi over 2 to pi over 2. And then for cosine, it's between 0 and pi. And then for secant, it should be between 0 and pi over 2, and then pi and 3 pi over 2. And then for inverse cosecant, it should be from 0 to pi over 2 and negative pi over 2 to negative pi. So please remember these values for the inverse functions when you are evaluating the limits. And then for trigonometric functions, the special angles will be very um, helpful for you. So I need you to remember the unit circle and the values of sine and cosine on these special angles. Actually, even if you just remember the first quadrant and then just flip the angles accordingly, you can get the other angles too. And next, I can also remember that we had this technique for limits involving exponential functions. So specifically when we have exponential in the numerator and the denominator, we need to determine when x goes to either positive infinity or negative infinity, because this is this the technique depends on whether it's positive infinity or negative infinity. So for the first case here, if it's positive infinity, as you can see, note that our graph, since we have here e is greater than 1, right? So our graph that we need to use is this part. And we want to remove the indeterminate forms, right? Because if we evaluate our limit here, you'll have 2 times infinity minus 1 over infinity plus 2. So that's just equal to infinity over infinity. So what we do instead of making this infinity over infinity, we need to multiply something to the numerator and denominator so that it becomes relate our function is now in terms of e raised to negative x and not e raised to x, because if it's e raised to negative x, then as you take the limit x goes to positive infinity, the limit is now approaching 0 instead of infinity, and therefore it's now simplified and we can solve for the limit. So how do we get e raised to negative infinity? So we can divide both the numerator and the denominator so that the e raised by e raised to x, so that the e raised to x will disappear. So I have 2e raised to x minus 1 over e raised to x plus 2 times e raised to negative x, or 1 over multiply by, 1 over e raised to x, 1 over e raised to x. Or this is actually equal to e raised to negative x over e raised to negative x, right? So we actually multiplied by that one to remove the e raised to x here. So simplifying, we'll now have limit of 2 minus e raised to negative x all over 1, 1, 1 plus 2e raised to negative x. X goes to positive infinity. And now, evaluating this limit will now have 2 minus 0 over 1 plus 0. Therefore, the limit is 2. So that is it for the first case. Now, for the second case, as x goes to negative infinity, so again, notice that the base of our functions here is e. E is greater than 1. So actually, if we evaluate this one, we'll have 4 times e raised to negative infinity, so that is 0, minus e raised to negative of negative infinity, so that's positive infinity, all over 6 times e raised to in negative infinity, so that's 0, minus e raised to negative infinity, so that's 0 again, 0, and then plus e raised to infinity. So as you can see, we have a problem with this one. These terms, e raised to negative 2x and e raised to negative x. So we want to multiply our function with something so that these two vanishes. So how do we multiply that? We can multiply by the one with the highest degree. 1 over e raised to n x, where n is the highest degree. Absolute value is the highest degree. So that is equivalent to taking 4e raised to 4x minus e raised to negative 2x all over 6e raised to 4x minus e raised to 2x plus 3e raised to negative x. I will be multiplying by 1 over e raised to this one, negative 2x. E raised to negative 2x. So that, and that, I will have, excuse me, limit of, but this is actually e raised to 2x. So I'll have 4 e raised to 6x minus 1 all over 6 e raised to 6x minus e raised to 4x and then plus e 3 raised to x, right? And so now that I have no negative integrals and negative exponents here, I can now plug in negative infinity, and thus this will become now 0 minus 1 all over 6 times 0. So that's 0 minus 0 and then plus 3 raised to 0. So I have negative 1 over 0. Sorry. And now I have 0 in the denominator, so I need to check the direction. But notice that for exponential functions, it's always above the x-axis. So no matter what, and these 3 in the denominator are all positive. Moreover, notice that if you increase the exponent here, you'll get a very large number. So assuming x is a large number, we can say that e raised to 6x overpowers these two numbers, and therefore this 6 e raised to 6x is too big, and therefore if you if you subtract e raised to negative e raised to 4x, it doesn't really matter, it's still positive, and therefore the direction should be 0 positive, and thus the limit is negative over positive, that is negative infinity. And so this is our technique. If we have a positive infinity, multiply by 1 over e raised to x, nx, where n is the highest degree, absolute value is the highest degree, to remove all e raised to x here. And then here, if it's x goes to negative infinity, multiply by 1 over e raised to the negative nx, where n is the highest absolute value of the exponent. Okay? Finally, for hyperbolic functions, again, I need you to memorize the graphs. And this identity for the cosine, hyperbolic cosine and hyperbolic sine. So when evaluating some limits, you can use e raised to x plus e raised to negative x over 2 for hyperbolic cosine. And then for hyperbolic sine, it's e raised to negative e raised to x minus e raised to negative x over 2. And then for the other functions, you can derive it using these two functions. Okay, so that's it for Unit 1. If you have any questions, feel free to message me. Okay, that's it. Thank you.